Hello friends, welcome back to my YouTube channel. So in today's video we'll see the one more problem of 3-inch arch. We'll see the design of 3-inch parabolic arch. In last video also we have seen one problem. Today also we'll see one more problem. So the given problem is like this. A 3-inch parabolic arch of span 3 meter and rise 4 meter carries a UDL of 20 kN per meter over left of span. Determine support reaction, normal thrust and radial shear at a distance of 5 meter both from left support, and also find magnitude, position of maximum positive and negative bending moment. So this is the given problem. So first what we have to do is we have to draw the arch diagram. So what they have given a 3-inch parabolic arch of span 30 meter. Span span 30 meter and rise of 4 meter. This is the ground. This is a point A, point B, this is point C, call it as. From here to here 4 meter rise and a UDL of 20 kN per meter over left of span. UDL act at left support, that is 20 kN per meter, and determine the reaction, a normal thrust and radial shear at a distance of 5 meter from both from left support. So now we'll see one by one. So first we have to find out the reactions, that is RA and RP, and this is the H, horizontal thrust. So we'll see. First we have to take the summation of Fy is equal to 0. So summation of Fy is equal to 0, it means all the upward forces equal to the downward forces. So RA and RB are upward forces. I am taking RA plus RB is equal to, this is moving downward, is equal to UDL is 20 into 15. So our total span is 30. It means UDL is acting is center to your left side. From here to here means the distance from here to here is 15 and here to here is 15. We need to take that 20 into 15. So RA plus RB is equal to 20 into 15, multiply, will get 300. Call it as equation number 1. So now taking moment about A at point A. So now the one more sign convention we have to remember. The bending moment moving which is upward is taken as positive, and downward like this which is moving downward direction taken as the negative, and all the upward forces are taken as positive and downward forces are taken as negative. This is the sign convention we have to remember while calculating. We have to apply. So now we are taking the moment about A. It means we need to take the from this side. We are taking moment about A means summation the reaction RA into from here to your distance is 30. RB into 30. RB into from here to here 30 minus, it is moving downward. So that's why we need to take the minus 20. 20 into distance from here to here is 15. 15 into 15 divided by 10, the UDL acting at the center, so that we need to take the half of the distance. That is nothing but 15 divided by 2. I have taken is equal to 0. Now simplify this. RB is equal to, I have multiplied this, it will come out as 2250 divided by 30. So it will come out as 75 kilonewton. This is the RB. So now we get the value of RB. Now put RB value in equation number 1. We'll get the RA value. So equation 1 is RA plus RB is equal to 300. So RA is equal to RB value. Substitute RB minus. So RA is equal to 300. 300 minus I have taken RB to right side minus RB. So now substitute the value. 300 minus RB is RB value we got a 75. So 75. 300 minus 75. It will come out as 225 kilonewton. This is the value of RA. So now next we have to take the taking movement about C from left side. From left side movement about C we have to take. I will redraw this diagram to here to better understand. This is the C, this is RA. So this is rise 4 meter. From here to here is 15. This is point C. Here H horizontal thrust. So now what we have to do is 20 kilonewton meter. Taking moment about C I am taking. Now RA, it is moving clockwise. So RA into 15. So RA into distance 15 minus 20 into distance, that is 15 divided by half of the distance. 20 into 15 divided by 15 divided by 2 minus, it is moving anti-clockwise horizontal thrust, that's why I have taken negative. H minus this distance from here to here. How much? From here to here, same distance from here, 4 meter, that is. So H into 4 meter. H into 4 is equal to 0. So RA value we got was how much? RA value we got was 225. So I have substituted 225 into 15 minus, I have simplified this, it will come out as 2250 minus H into 4. So now I have rearranged this. H is equal to, rearrange this, I have calculated. So 3375 minus 2250 divided by 4. So 3375 minus 2250, it will come out as 1125 divided by 4. So by dividing it will come out as, after dividing, 281.25 kilonewton. This is the value of H horizontal thrust. So now we have to calculate the maximum positive bending moment. So usually maximum positive bending moment occurs at the maximum loading portion. So here the maximum loading portion is here from left side. So it occurs, maximum positive bending moment occurs at this portion. So I will read out this to here to better understand. This is the 20 kilonewton meter, 4 meter horizontal thrust. This is reaction RA. Distance is 15. So RA value we got was 225. H value we got was 281.25. So now I am taking, so RA is equal to, so I am taking moment about C from left side. Taking moment about C at this point C from left side. So now reaction the RA into X. So if we cut the section like this from here to here, it becomes x, and from here to here it becomes y. So RA into this distance, RA into x, RA into x minus the UDL is 20 into x. From here to here is x divided by 2. So I have directly taken here x square. It means our UDL is always act at the center, that is 20 into here to here distance is x into x divided by 2, half of the distance x divided by 2. I have directly taken 20 into x square divided by 2, and minus this is acting anti-clockwise, that's why I have taken negative, minus horizontal thrust. So h into this distance from here to here distance y, here to distance is y, h into y, horizontal thrust into this distance is y. So now substitute the value. RA value we got was 225 into x minus, I have divided 2 ones 2 tens, 10 into x square minus our h value is 281.25. Our y value is, so we have the one formula to calculate the y, that is 4hx divided by L square into L minus x. So for h is how much from here to here is 4. So our x is as it is divided by our L is how much, our span is 30 square, L is 30 minus x is as it is. So simplify this, 4 into 4 16x divided by 30 square, 30 minus x. So now simplify this, 16x into 30 divided by 30 square minus 16x square. I am multiplying this 2 inside, divided by 30 square. So 30 will get cancelled. By simplifying, it will come out as 0.53x. So 0.53x minus 0.017x square. So this is y value. Substitute this value in here. I have substituted y value here, which we have calculated just now. So I have substituted here. So 225x minus 10x square minus, I have multiplied this into inside, it will come out as 149.06 x plus minus into minus plus this into this. By multiplying, it will come out as 4.78 x square. So I have simplified this. This is the simplified version of this, and I will call it as the equation number 2. Now what we have to do is we have to do the differentiation for this equation. So differentiation of this equation. So d is equal to, I have put this value here as it is. Now we are differentiating with respect to x. So differentiation of x is 1. So 75.94x, the differentiation of 75.94x, it will be 75.94 minus differentiation of 5.22 is constant, so I am putting that as it as same. Differentiation of x square is equal to 2x, so 2 into x. So now I have simplified, x is equal to as it is, I have taken this to this side. So 75.94 divided by 2 into 5.25, by multiplying, it will come out as 10.44. So by simplifying, it will be come out as 7.273 meter. So now substitute this x value in equation number 2, will get the maximum positive bending moment. So putting this x value in this equation. So 75.94 into 7.2 73 x value I have substituted, minus 5.22 into x value I have substituted here, and by simplifying it will come out as 276.19 kilonewton meter. This is the maximum positive bending moment. Maximum positive bending moment. In the same way, we have to calculate the maximum negative bending moment. So maximum negative bending moment occurs on non-loading portion. So it means it occurs here, non-loading portion. So now I will draw this to here. This is a non-loading point C, RB, distance 15. This is the horizontal touch. So our RB value we got was 75. So H value we got was 281.25. So if you cut the section, so like this is the X and this is the Y. So now taking moment about C, so RB it moves clockwise, so moving upward, so RA plus RA into X, so RA into this distance X minus this is moving anti-clockwise, so H into this distance Y, so our H is 281.25 into Y distance, this is Y. So for this Y is same now as what we have calculated for calculating the maximum positive bending moment, the same. The Y value is same, we have to substitute the same value. So now simplify this. By simplifying it will come out as 75x minus, by multiplying it will come out as 149.06x plus this into this 4.78x square. So now what we have to do is again we need to, so this is called as equation number 3. Again we need to do the differentiation. So now I will show here. So differentiation of minus 74.06x plus 4.78x square. So differentiation of minus 74.06 plus 2 into 4.78x. So by simplifying it will come out as 74.06 divided by 9.56. By simplifying x will come out as 7.74. Now substitute x value in this equation. Here we need to differentiate with respect to x. So after finding out x value we need to substitute in this equation. So I am directly substituted x value in this equation. So minus 74.06 into x value is 7.74 plus 4.78 into x value is 7.74 square. So by simplifying it will come out as, by simplifying it will come out as minus 286.87 kilonewton meter. So this is the value of maximum negative bending moment. So maximum negative bending moment is minus 286.87 kilonewton meter. So this is how we calculate the positive and negative bending moment. So remember, always the positive bending moment occurs on the loading portion, and the negative maximum bending moment occurs on the non-loading portion. If you see the diagram, it will come out as I will show. So the diagram will be like this. The x distance at this support is 7.27 x, at this is 7.74. So the positive bending moment is 276.19 276.19 kilonewton meter, and negative bending moment it will come here, that is 286.87 kilonewton meter. So it means the diagram it will come out like this. This is the negative, this is the positive, so it will come like this. The diagram will come like this. So now we'll see the calculation of normal thrust and radial shear at 5 meter from the left support. So to calculate the normal thrust, we have the formula HD cos theta plus VD sin theta. Here what's the unknown? We have the value of H. So H is nothing but our HD. So we don't know the value of VD. Now we need to calculate the VD value, and also we don't know the value of theta. So now one by one we'll calculate that. We'll see how to calculate. So to find out the theta, we all know the formula tan theta is equal to dy by dx. So tan theta is equal to dy value we have the formula for calculating the y. So the formula is 4hx divided by L square into L minus x. This is the y formula. So now substitute in this equation, and by simplifying we'll get the theta value. So now differentiate this. So differentiation of 4h divided by L square x into L minus x. So 4h divided by L square is constant, so I am taking it as outside. So now I'll differentiate. I will show you here. So first 4h divided by L square is constant, I am taking outside. So dy by dx, I am multiplying x inside, Lx divided by x square. So 4h by L square constant, differentiation of Lx is x, difference of Lx is L. So differentiation of x is 1, so L is constant as it is L. So differentiation of x square is 2x. So same I have written here. So now we know the value of H and L. So I will draw the diagram. So our L is span is 30, our rise is 4 meter, and this is the UDL 20 kilonewton meter. From here to here is 15. RA, RP, H, here H. So our H value is 4. So I have our H value is 4. I have written our L is span is 30. So now what they have said to calculate the normal thrust and radial shear from left side at a distance of 5 meter. If it means if you cut the section like this, here to here distance 5 meter, we need to calculate the normal thrust and radial shear at a distance of 5 meter from the support. So that here x value will become the 5. So 4 into 4 divided by our L is total span. We need to take the total span length, that is 30. So L is 30 minus 2 into x value is 5. So now substitute all the value. By simplifying it will come out as 0.35. So now theta is equal to, I have taken tan to this side, it becomes tan inverse of 0.35. So theta is equal to tan inverse of 0.35, it will come out as 19.29. So now substitute our normal thrust formula is HD cos theta plus VD sin theta. So we have the value of HD and the theta value also we got. Now what we have to do, we need to calculate the value of VD. So it means I will, so at left support, so we need to take only this, we need to assume only this portion, we need to neglect the this right portion. So here at left portion the reaction is RA and on UDL is acting, so we need to take dot VD. I will show here. It's 20 kilonewton meter. We need to find out the 5 meter distance only. So RA. So here on reaction is one force will take place, that is VD horizontal, here also HD. So to find out the VD, we need to take the upward forces is equal to down forces. The upward forces is RA is moving upward, so plus RA, say VD is coming downward, so minus VD, and UDL is coming downside, so that is 20 into at a distance of 5 is equal to 0. So I have rearranged this. RA is equal to VD plus 20 into 500. So now we need to calculate the VD. So I am taking VD is equal to RA minus 100. So RA value we got was how much? So RA value we got was 2 to 5. Now substitute RA is 2 to 5 minus 100. So it will come out as 125 kilonewton. So VD is 125 kilonewton. Now substitute this VD in this equation. So HD value is 281.25, cos theta is 19.29 plus 125, or VD is 125 into sin theta value is 19.29. So by simplifying, our normal thrust value come out as 306.75 kilonewton. So now we will move to the radial shear. For that we have the formula HD sin theta minus VD cos theta. HD value we got was 281.25, sin theta value is 19.29 minus 125 cos theta 19.29. By simplifying, it will come out as minus 25.07 kilonewton. So this is how we calculate the normal thrust and radial shear, and also the maximum bending moment and maximum positive bending moment as well as maximum negative bending moment. So I hope you all are understood. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.